you out. Or in the break time when it is there, you can ask them the questions, the concerned counselor. But not every counselor is from the IGNU. So not everybody will be able to take up your question, address your query properly, be your satisfaction. Only the academic questions that are concerned with that particular session needs to be asked in that the session, unless the counselor specifies that you can ask any questions.
Yes, actually, this happens because students are not regular from the first day, and there are many queries regarding where are the study materials, where is the link for this and that. So that's
No,
okay.
all the information has been shared to everybody in their email ID. I have been saying this repeatedly to whoever email ID that we got from database, that we have shared with everybody. And there are people who knows this, so you can ask in the group, in the peer group. Your friends could help you in the WhatsApp group. So why to take up extra time for that, which is meant specifically for your theory and practical counseling. So let us utilize this time in a better way, properly, to enrich ourselves, to increase our knowledge. Other than that some administrative question. Those questions are important. I'm not saying that, not denying that, but you need to find the suitable time for which is suitable for that. Okay. So all the best.
Okay, let's start today's session. uh, Today's session is regarding the course MGY 003 and MGY 103. 003 is for the certificate program in geoinformatics, and MGY 103 is for the MSc students. So as you can see, this course is regarding global navigation satellite system and geographic information system. Here, this is geographic, this GNSS, that is Global Navigation Satellite System. This plays an important role in in our daily transportation systems, like the navigation, the aviation, the weather forecasting, and also for many this environmental management programs. And what GIS does, that is Geographic Information System, this allows us to view and understand and also to interpret and visualize data in many ways. That tells us the relationship, the patterns, the trends in the form of maps, in the form of reports, and also charts. So this GIS helps us to answer questions and solve the problems by looking at the data in the way that we can understand, and we can also share them easily. So today we will be talking about the basics of this GNSS. And for the GIS part, there will be another counseling sessions by I think tomorrow by Dr. M. Prashant, and for GIS database creation and GIS analysis part will be taken by Dr. Sunil Londe. For the certificate program, there are 3 units in block 1, that is introduction to GNSS and its components, and GPS survey and application. And for the PGDGI and MSc program, the block 1, it consists of the 4 units, that is introduction to navigation satellite system, navigation satellite programs, GNSS based survey, and application of this GNSS. So in unit 1, you see This is regarding the introduction to the GNSS. And here we have divided for the PGDGI and MSc students the third unit, that is GPS survey and application. And this is divided into two units, GNSS based survey and application of GNSS. So just a minute. Okay. You see, before we discuss about the global navigation satellite system, let us know about the term positioning. This term, positioning, this term is used to describe the determination of the location of one position that is relative to the other position, or we can say that positioning, this is the determination of the coordinates of a point on, it can be a point on land, it can be point on sea or in space with respect to the coordinate system. So this word, the positioning with respect to GNSS, this is used to refer to finding the position. So therefore, this positioning, this includes not only the location, but also the direction of the positioned object. So here we use real-time positioning. That is real-time positioning. This it refers to the location in real time, obtaining a location in real time with no delay between the appearance in a location and availability of the positional information about the same location. So there are two more terms like spatial positioning and geospatial positioning. By spatial means this is having to do with the space, or which is related to space. And the term spatial positioning, this refers to the positioning system which determines the location of an object in space. And for this geospatial positioning, this term, this deals with the positioning in a geographic sense, or it deals with the positioning of the geographic coordinates. And there is also another term that is called geolocation. Geolocation is nothing but it refers to the to identifying the real world geographic location of a GNSS receiver. And we should also know another term, that is reference point. This reference point is also known as the control point in surveying. And it is the you see, location used to determine the location or position of another reference point by giving the relative position. So this reference point is also known as the control point in surveying, and is the location used to determine the location or position of another one. So these are the terms. This is specially used in any GNSS program. So now let us talk about what is GNSS. You see, in 1970, the International Civil Aviation Organization defined GNSS as a worldwide position and time determination system that includes one or more satellite constellations, the aircraft receivers, and system integrity monitoring, like the augmented as necessary to support the required navigation performance for the intended operation. So this is the definition given by the International Civil Aviation Organization in 1970. So you see, there are many global navigation satellite system operating all over the world. The US, this global positioning system that in short we all know as GPS, the European Galileo system, the Russian Federation, this global navigation satellite system, that is the GLONASS, and also the compass system. This compass system is of China's navigation satellite system. And we all know about the Gagan, that is Indian GPS aided geo augmented navigation by India. So now coming to the components of GNSS, you see GPS, GLONASS, Galileo. These are the three main GNSS system, and all these technologies consist of three main segments, or we can say as three main components. And these are the space segment, the control segment, and the user segment. For the space segment, it consists of GNSS satellites like space vehicles that send radio signals from the space, like the satellites in the sky. Then for the control segment, that is the ground stations, it consists of a system of the tracking stations. They're located around the world, like the network of monitors, or they control the segment, they tracking stations, like the tracking stations, they control the signals from the space. And the other important part is the user segments. That is, it consists of GNSS receivers, and these receivers, they convert the space signals into positions, signals of the velocity, the time estimates, which are used by users like us for navigation, for positioning, for any other research. So this is the important segments which we the users use. So there are three components: space segments, control segments, and the user segment. So
Ma'am, please share the previous slides, please.
sorry, you want to
Previous
go
slide back. Please share. Yes, yes, right.
you were writing it?
Yes, ma'am.
No need to write. I will share this recording, and these are already there in your SLM, in your this books. Okay.
No, okay, ma'am. Okay.
I have done nothing outside from your book. It is there already in your SLM, and this recording will also be provided to you. You just listen to what I am speaking, and if there is any doubt, you can ask me.
Okay, ma'am. Thank you.
These are the basics, and uh, these are the very basics of this navigation satellite system, right?
Yeah, okay. Ma'am, actually, this is the Gagan. This is the latest of the satellite.
Sorry?
Gagan is there, ma'am. This is the latest of the satellite, or? position. Hello.
You can explore there. You see there are many updates coming up, right? Every now and then there are many updates. You can go for the latest information. I am just talking about the basics of the GNSS, and
Okay.
that are being provided in your booklet.
Okay.
And if you have any other information, you can share here, and we all can enjoy listening to you, right? Okay, so whether it is GPS or GLONASS or Galileo, they determine the user's terminal position through the time of arrival and the mode of ranging. So ranging is like this is a kind of technique that is based on the measurement of time interval that is employed by a signal transmitted by a satellite or by a radio signal, and that is known as the location to arrive at the user's receiver. Here, as you can see, distance is equal to velocity of light into travel time of the satellite signal. This means that distance from any known position of the satellite to the receivers end, this is equal to the velocity of the transmitted light, that is multiplied by the travel time of the radio waves that is transmitted from the satellites that reach the receiver. So here you see they determine the terminal position through the time of arrival. So this is regarding the distance. And coming, if we take an example, you see we have already studied this in our school days in the physics lesson, where you can see the distance is the time of the this is an example of the lightning, that is the distance is the time of the lightning that flashes observed, that is called the, when we observe the flash, this is called the start time, and where until the thunder is heard when we hear it, and that is known as the stop time. So this is multiplied by the speed of the sound, that is at an approximate of 330 meter per second. So the difference between the start and the stop time, this is referred as the signal travel time. So in case of lightning, the signal is the sound wave that travels through the air. So here this is regarding the signal travel time, and in case of lightning, as in this example, the lightning, this is the signal is the sound wave that travels through air. So this is regarding the distance and the travel time and the speed of the sound, how it is being transferred from the space segment to the control segment and to the user segment. So here now coming to the principle of GPS. When we talk about the principle of GPS works on a principle, this is called time of arrival, or it is the short form, it is written as TOA or TOA, and sometimes this is also known as time of flight, that is TOF. So time of arrival is the travel time of a radio signal from a transmitter to a remote signal receiver. So time of arrival of a signal measures, that is measured by the user. This is known as TOA, equal to the time instant of arrival minus time instant of transmission. So the principle of GPS, this works on the principle called time of arrival, and this is also known as the time of the flight. So details are there in your SLM, where more details are there regarding this principle. You can go through it. So another is important is the geometric distance. So geometric distance, this can be obtained between the satellite and the receiver by calculating the true time of arrival. How this GPS works? By calculating the true time of arrival, that is the signal obtained from the satellite and the receiver by calculating the true time of arrival. And this indicates that the receiver has a you see, accurate knowledge of time instant of arrival and time instant of transmission of the satellite signal. So here time instant of the arrival can be achieved through direct reading of the this receiver clock, whereas the time instant of transmission is embedded in the signal, which is scheduled by the navigation signals. So this is also important principle regarding the geometric distance of the GPS. And now if we talk about the history of GNSS, you see LORAN, that is the long range navigation. This is LORAN, the primitive navigation system, which is known as the long range navigation. The first, it was developed in early 1940s by USA, which became operational in 1943. And this was the first radio navigation system that provided aid to marine radio navigation. And based on the principle of time difference between the receipt of signals from a pair of radio transmitters, and this long range navigation, this covered only 5% of the Earth's surface and provided two-dimensional information. So the history, this starts in 1940s by USA, and this LORAN, this became operational in 1943. And after that, you see in early 1960s, the importance of GNSS was first realized by the US Department of Space. And this leads to the development of the navigation system. This is named as Omega. And this was approved by USA for development in 1968, and this became operational in 1971. And also the Omega, this was shut down in 1997. And this was the first radio navigation system for the aircraft, which was operated by US in cooperation with 6 partner countries, such as the Argentina, Norway, then you see Liberia, then France, Japan, and Australia. And this enabled the ships and the aircraft to determine their position by receiving very low frequency radio signals. So after that, in early 1960s, only the US developed and deployed the first satellite-based navigation system, which is known as the Transit, and this is also known as NavSat, like this Navy navigation satellite system. And primarily this is used by the US Navy for determining the accurate location information. So this transit, this provided continuous navigation satellite services from 1964 to 1966, initially for the Polaris submarines and later on for the civilian uses, and also used for the geodetic and also for the hydrographic surveying. And you see, introduction of the GPS, this made transit as an obsolete system. So the major breakthrough came into the introduction of American Napster. This is commonly known as the GPS. So after this transit, which is known as the Napster, the GPS came into it. So then the modern GPS, this came into existence in 1973 when US Department of Defense, they decided to develop the satellite navigation system that was based on its previous system, the transit. So GPS was the only was only intended for US military application. So in 1980s, the system was made available for the civilian uses, especially in aviation industry. And by 1994, the complete, you see, constellation of 24 satellites was in orbit, initiating the GPS system full operational capabilities. So today you see millions of GPS receivers are being used in transport, used in commerce, and also in variety of activities. If we talk about the Cold War, this conflict between the USA and the former Soviet Union, this lead to the space race, we can say, and almost this is the parallel development of the GLONASS, which is this GLONASS is the Soviet system. So here comes the history of the GPS, the GLONASS. Now, if we talk about the GPS, here you see GPS, this is a space-based as on GNSS. This is maintained by the US government, which is freely accessible by anyone with a GPS receiver. So there are three phases. In phase one, where from 1973 till 1979, the concept of this validation started, and then this phase two in 1979 till 1985. The full development and the test was going on, and in phase 3 till date, that is 1985 till date, the production and the deployment of the GPS is going on. This is regarding the history of the GPS. Also, you see this GPS in 1993, the GPS achieved that I have already told that this achieved the initial operational capabilities with a full constellation of 24 satellites, and was available and provided the standard positioning services that we in short we say as SPS. And in 1995, the full operational capacity, that is FOC, this was achieved, and the 5 years later, the accuracy for the civilian users increased this increased from 100 meter to 20 meter, and as a result, this was this deactivation of the selective availability. This is selective availability is nothing but you see GPS formerly they included a feature called selective availability, or in short we can say SA, that was an added intentional time fluctuating error, which is up to 100 meters. This is available to the publicly available navigation signals. So this was intended to deny any enemy, the enemy that is used for the civilian GPS receivers. So that was an intended error. So for this selective availability, here for the GPS, there are some errors. You will read about this in the errors regarding GPS, which is one of the important error which we say as selective availability. That is an intentional error. That means the time fluctuating error, which is up to 100 meters, which is publicly available for all navigation signals. This is one of the error. So these are some of the errors you will study in when you study the errors, you will study about the selective availability, and also for SPS, as I have already told, this is the positioning and time service that will be available to all GPS users on a continuous worldwide basis. And for PPS, that is precise positioning service, this is an highly accurate military positioning and the velocity and timing service, which is available continuously worldwide to users that are authorized by the US. So these are the two words you have to study, the SPS and PPS. You go through the through your learning material. Details are given there. So these are some of the characteristics that yeah, it's available there. The history and the characteristics of the GPSs. Now coming to GLONASS, you see, GLONASS is a satellite that is satellite-based radio navigation system that provides the positioning and timing information to users, which is similar to GPS. So it is operated by the Ministry of Defense of the Russian Federation. And during the period of over 3 decades, the GLONASS has they have gone through numerous improvements, which can be divided into 3 generations, like the original GLONASS, which is since 1982. Now this is out of service. Then GLONASS M, that is operational since 2003. Then GLONASS K, this is operational since 2011. GLONASS K2, this is operational since 2014 to 2014. And there are also future satellites. They are termed as GLONASS V and the GLONASS KM, which will come up, projected to become coming up on 2030. So these are also the characteristics, the year-wise the types and the characteristics that is given. And likewise, you see, like GPS and Galileo, GLONASS also have 3 segments: space segment, control segment, and user segment. And for the space segment, this also consists of satellites located in middle of the circular orbit. And the constellation, this operates in 3 orbital planes with 8 evenly spaced satellites on each. So fully operational constellation with global coverage, this consists of 24 satellites. And while only 18 satellites are necessary, if we talk about the Russia, territory of Russia, only 18 satellites are necessary to cover the territory of Russia. And GLONASS especially, this is useful for the users in northern latitudes. So coming to the control system, this also consists of the control system and network with commands tracking of stations from across the Russia. And here you can see there are terms like ephemeris. This is a table of values that gives the position of astronomical objects in the sky. And there is another term that is UTC, that is Universal Coordinated Time. This is nothing but the primary time standard by which the world regulates the clocks and times. And coming to the user segment, this consists of equipment that tracks and receives the satellite signals. And this equipment is capable of simultaneously processing the signals from a minimum of 4 satellites to obtain any accurate position, and which position you will also get the accurate velocity and time measurement. Like GPS, this GLONASS, this also this is also useful for the military and the civilian users. Now, if we talk about, after GLONASS, if we talk about Galileo, Galileo also, this is the global navigation satellite system that went live in 2016, which was created by the European Union through this European GNSS agency, which is headquartered in Paraguay in this Czech Republic, where with 2 ground operational centers, which are named after the famous Italian astronomer Galileo Galilei. And this Galileo, this is the new generation of, you see, universal services in various sectors like the transport, telecommunication, agriculture, and fisheries. And this Galileo program, this also managed and controlled by the civilians. And this provides a large variety of services, like some of the services, you see, Galileo, this also results with the combined use of Galileo is also used with other system. This is combined with other systems, and Galileo provides multiple level of services to users throughout the world. So these are regarding the Galileo. This also has the satellite control, then control center, then also the user segment, which is also known as Galileo sensor stations. And for the user segment, this is same as the GPS and the Galileo. So all the navigation satellite system, they have the space segment, the control segment, and the user segment. So coming to another GNSS system, that is BIDO or BDS. This is a GNSS system which was commissioned in 2020, and this is owned and operated by the People's Republic of China. And this BDS was previously known as Compass. This operational system, this consists of 35 satellites. So the first generation experimental satellite of BIDO 1A, this was launched on 30th October 2020, 2000. And the official website of the video navigation satellite system, this went online on the 15th January 2010. So this video, this is China's GNSS system. Now coming to the most important part, that is the Indian scenario. So if we talk of the Indian scenario, ISRO, this ISRO set up a project to implement the Indian regional navigation satellite system over the Indian region. So its operational name is you see NAVIC, that is the full form is Navigation with Indian Constellation, and its primary service area covers the entire Indian subcontinent, and also it extends to some of its neighboring countries. Coming to Gagan, that is geo-aided, geo-augmented navigation. This is planned implementation of a regional satellite-based augmentation system, that is SBAS of the Indian government. So ISRO and AAI, that is Airport Authority of India, have implemented this GPS aided geo augmented navigation, that is Gagan project, as a satellite based augmentation system, that is SBAS, for the Indian airspace. This is especially for the Indian airspace. So the objective of Gagan is to establish and to deploy and certify satellite-based augmentation system for safety of life, this civil aviation applications in India. So Gagan, apart from aviation, this provides benefits to many other user segments, such as intelligent transportation, marine, then the highways, railways, surveying, geodesy, security agencies, telecom industry, and also for the personal users of position location applications. So these are some of the application of Gagan. So now comes another GPS, that is DGPS. That is nothing but differential GPS. This was deployed to meet the requirement of positioning and distance measuring applications that require the best accuracies. So you see, differential GPS, this is a method of increasing the accuracy of positions that are derived from GPS receivers. So with DGPS receivers, the position accuracy is improved from 30 meter to better than 10 meter. So this differential global positioning system, that is DGPS, this is nothing but this is a more accurate technology than its original GPS. So the accuracy in DGPS is improved. Why it is improved? Because it uses two receivers instead of using only one receiver, which finds this where you can find the precise location relative to the position. So the difference between the GPS and DGPS is that DGPS is more accurate technology, and it uses two receivers instead of using only one receiver. So these are the basic comparison between GPS and DGPS. So now coming to the principle of DGPS, you see the principle of DGPS is that, as I told, that any two receivers that is relatively close together, they experience similar atmospheric errors, and it is necessary requirement for DGPS that GPS receivers is to be set on a precisely known location. This you should know the location. So we can say that GPS receiver is the base or the reference station. So the base station receiver, they calculate its position based on the satellite signals. So then this location is compared to the known location. So the difference is applied to the GPS data that is recorded by the second GPS receiver, which is known as the roving this receiver. The second GPS receiver, this is known as the roving receiver, and the corrected information can be applied to data from the roving receiver in real time in the field whereby using the radio signals. So the principle of DGPS is that any two receivers that is relatively close together experience the atmospheric errors, and it is necessary requirement for the DGPS that the GPS receiver is set on any precisely known location. So the principle of the DGPS is based on two receivers. So there are also some comparison given between a survey related to GNSS and the conventional surveying methods. Definitely there are advantages of using GNSS over the conventional surveying method, which we all know. And now, while planning a GNSS survey, you see a GNSS survey, this is different from conventional surveying, we all know. So this GNSS survey requires a very careful planning, careful execution, and also some careful processing techniques. So systematic planning always maximizes the chances of having less this accurate, having means more accuracy. So within a reasonable time and budget, this also depends, the budget also depends, the time also depends on any survey. So before you go for any GNSS survey, one must decide the purpose of the survey and also the accuracy you want, the results you want. So there are several parameters like the satellite configuration, then the number and type of receivers to be used, for any GNSS survey. So there are some elements that decides for a GNSS survey, like you have to design the project design, the observation scheduling, how you are going to visit those stations, and for the instrumentation and personal consideration also. Instrumentation, like every GPS, they have their own means the manufacturer have their own requirement, as far as then you need calibration for that instrumentation. There are also logistical considerations. So these are some of the planning you need to do for any GNSS surveying. So there are also some techniques regarding GPS measuring techniques. We will be doing one practical regarding this GPS data collection, and how you will be plotting this GPS readings in your software. We will be doing one exercise or lab exercise regarding this, which I and Sujang will be taking, I think on 26 November, that is Sunday, on the second half. That is an important exercise. It is requested all of you to attend that, where you will know how you can collect the GPS data and how you can transfer those GCP points to your software that you are being used. So this can be discussed that day. So coming to the application part, as we all know, we are discussing, and we all know that there are many applications regarding GNSS. It's been used in navigation anywhere in airspace, in land, water, and all. And right now you're using the remote sensing and GIS application, and also we all know that this is very useful for surveying, for mapping, for geodesy. Then this is nowadays used many ways for natural disaster, for environmental management, and the weather studies. And for agriculture also, there are many researches going on using remote sensing and GIS. And for the location-based service, we all use it daily, which is inbuilt in our smart watches, smartphone, which knowingly or unknowingly we are using remote sensing and GIS techniques. So this is all about GNSS. So as requested, I think if we can have a break for 30 minutes, as one of you have asked. But if there are any questions, I'll be happy to take them. Thank you. I think Desmukh sir is also here. He can also help. Yes, please.
Hello, ma'am.
If there is no question, we can have a 30 minutes break, and you can join after 30 minutes. I think at 1:15 we are having practical class.
Sure.
Hello.
Yes.
Sure, ma'am.
Yes, please.